My dear students, I hope all of you are fine and doing well. So here we are going to discuss today the chemical properties of the nitric acid. The nitric acid, it is also known as the oxy acid of nitrogen, and it's a lot of chemical properties because it is too much chemical reactive. So that's why it can make a lot of different types of the compounds by reacting with the other substances. On the other hand, when we draw its structure, it is HNO3, which is its molecular formula, and on the one side, which is the central nitrogen atom is present in it. Now, how do it chemically react with the different types of the substances? Half of the one we have already learned in the previous lesson, and the remaining one we will learn today. So the first one is its reaction with the mercury. The number one mercury, it gives mercurous nitrate and the nitric oxide when it got reacts with the dilute nitric acid. So here we have the mercury symbolized as Hg. It will be only metal that is present in the liquid state in nature. When it reacts with the nitric acid, it produces mercurous nitrate, which is Ag2NO3 whole twice, and nitrous or nitric acid and the dilute nitric acid on reacting with this, which is the production of the water. But on the other hand, when it got reacts with the concentrated acid, it gives the mercuric nitrate and nitrogen dioxide. So here we have again the liquid mercury. It reacts with the concentrated nitric acid and produces mercuric nitrate and nitrogen dioxide along with the production of the water molecule. So when it is in the dilute state or when it is in the concentrated state, its products are always different because its reactivity depends upon that whether it is in the liquid state or whether it is in the solid or in the concentrated or dilute state. So the second is it's the reaction with the tin. Tin is the metal like as SN, and here it is in the solid state. On reacting with the dilute nitric acid, it produces SnNO3 whole twice. This is the product produced by the nitric acid when it reacts with the tin. On the other hand, when it got reacts with the concentrated nitric acid, then it produces the H2SnO3. So these two products are totally different from one another because we have just changed the acids by its dilution or by changing its concentration. So the two different products we gain as a result of this process. Along with it produces the nitrogen dioxide when it is in the concentrated form, and when it is in the dilute form it produces ammonium nitrate, and the water molecules are produced in both these processes. So this was a simple reaction of the tin, which is SN. Here the first process it produces a stannous nitrate, and in the second it produces a simple stannous oxide with the hydrogen. And the name of the acid over there, which is produced by reacting it in concentrated form, it is known as metastannic acid. Metastannic acid. But when it is in the dilute form, it reacts with the nitric acid. It just produces the simple product of ammonium nitrate, which is the main product in this process. After this, we have the third one, chemical property of the nitric acid, which is its reaction with the zinc. So when it got reacts with the zinc, which is a nitric acid, it is in a very dilute state. It produces zinc nitrite, ammonium nitrate, and the water molecule. But when it is in the simple dilute state to an average length, then the product is again zinc nitrite, dinitrogen oxide, that is nitrous oxide, and along with the production of the water molecule. And the third one, reaction when zinc is in the solid state, or here we take the zinc which is in the metallic state, it reacts with the nitric acid in highly concentrated form. The product is zinc nitrite, again nitrogen dioxide and the water molecule. So the thing which is common, it is the production of the zinc nitrite, but the thing which is different, it is ammonium nitrate in the first step, dinitrogen oxide in the second, and the third one it is nitrogen dioxide. So in this way, the zinc when going to react with the nitric acid in different concentration form, the products may be differ. That depends upon the totally which type of acid we are going to use. And then we have its reaction with the different reducing agents. The reducing agents here we have the like iron sulfate, we have hydrogen sulfide, we have hydrogen iodide. They are simply converted into the simple sulfate, sulfur and iodine respectively when they got react with the concentrated nitric acid. So here we are going to take all over the acid which is in the concentrated form. When it reacts with the iron sulfate, it produces the iron sulfide, nitrogen oxide and the water molecule. And in the second, when it got reacts with the hydrogen sulfide, which is a highly reducing agent, it produces water molecule, nitrogen oxide and the sulfur. And in the third step, when it reacts with the hydrogen iodide, which itself is a reducing agent, it produces the water molecule, nitrogen oxide and the iodine production. So the three reducing agents when they got react with this, it produces different types of the products like this. And at the end we have here the behavior of the nitric acid with different metals, that how do it behave when it do react with the different metals. Nitric acid behaves differently basically in different metals. The first one metal we have over there is gold, we have platinum as Pt, then we have iridium and we have titanium. They do not react with the nitric acid, and nitric acid is formula is as HNO3. On the other hand, the other metals like iron, cobalt, nickel, chromium, aluminium, they are rendered passive by the acids due to the formation of the film of their oxides over them. So they also do not react specifically with the nitric acid. Then we have the tungsten, which is denoted by W, and the uranium. They are changed into their oxides on reacting with the nitric acid. And the last one behavior is in which we have magnesium, have calcium and manganese. They give hydrogen with dilute nitric acid. So when these three react with the nitric acid, they produces the hydrogen as a result of this reaction. So this was all about today's lecture about the chemical properties of the nitric acid in detail. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section. The next topic that we will discuss it is the uses of the nitric oxide or the nitric acid in detail. For that time, you guys keep learning and have a good day.